To Biology 451, let's talk about image analysis, which is the last section in this course. So let's go. So, image analysis can be a lot of things. We've already learned about what are definitely image analysis components in techniques like cryo-EM and even X-ray crystallography, because you have to find the spots and map them and map the brightness of the different spots. And all of that is image analysis with an extra layer of mathematics thrown on top of it. But you can actually do just straight up image analysis. And so a lot of this gets called GIS, Geographic Information Systems is the name for it. And this is basically a way of mapping something that is interesting to humans onto a landscape. So you can map streets addresses, water features, plumbing, stuff like that, population density, onto an actual satellite map of an area or a field or even the entire Earth. And you can learn stuff from this. Now, included in this would be different kinds of satellite mapping. So the technical term for this is remote sensing. Remote sensing is when you're using a satellite to observe something that would be difficult to observe otherwise. And there are satellites that actually have orbit paths that take them not just over one part of the Earth, but actually wrap around the Earth in such a way that you can build up a nice picture of everything that's going on. It's what they do when they send satellites to Mars, for example. They'll have it circle around on one of these paths so that we'll pick up images of everything underneath it. And then what you can do with this is basically anything that you can see with a spectrometer, you can then analyze. So let's say you wanted to look at plant cover. So if we're talking about trees, those are going to be generally a darker green in satellite images. And so you can tune in on the wavelength that tree foliage would be and compare that to the lighter green, which would be something like grass. And you can separate it out. You can say, okay, how much of the world is covered in forests? This is how they actually come up with these numbers. When they say the rainforest is shrinking, it's because they can observe from space the rainforest, physically getting smaller, stuff like that. You can map the size of ice sheets. You can map population density. You can map voting records and population density to figure out all kinds of interesting things. So the main tool that everybody uses for GIS type analysis is called ArcGIS. And there are courses here and elsewhere. If you're going to get into this kind of, it's almost straight up geography, then ArcGIS is the thing that is the industry standard at the moment. It's what you would need to learn in order to go on. It's a paid for program, so we are not going to use that. We're going to use simple old ImageJ, which is put out by the US government and is free to you and me. So let's go. Okay, so a couple of concepts, sort of principles in interpreting images. An image is going to be, a reproduction of something. For the most part, the images that they're going to talk about are going to be satellite images of Earth. And the satellite images will show different things. Like, can you tell what this thing is in the center? Yeah, I don't know. If you, the clue would be if you count up all the little things that make it up, this thing that sort of looks like a fingerprint, that's a pretty good clue, I think. We'll see on the next slide. That'll help you. And whereas you might see this as, it looks like there's a road curling around. Okay, great. And some maybe cultivated fields over here, maybe some kind of, I don't know, civilization. If you zoom in, you can't really tell what's going on there. Maybe that's the side of a mountain. You can start to figure out what's going on here. But what the computer sees are pixels, which is just a square grid of little square spots of a different color. And each pixel contains a number. So the number in this case is going to refer to how dark it is. So you can, for example, put these on a scale of 1 to, or let's say 0 to 255. Or you can do much broader scales with sort of thousands of different shades of gray. And because you're dealing with numbers, you can actually use statistics on the numbers. You can highlight, this area right over here, which looks like a little pond or something. And you can highlight this area over here, and you can show that they are statistically a different color. Showing things are a different color may not mean much on its own, but if you ask the right sort of question, this is one of the ways that you can get an answer. For example, if you only look at wavelengths that chlorophyll would absorb, you can look for absorbance in, let's say, blue and red, which is what chlorophyll is best at. And you can map those, and you can get an idea of what is the photosynthetic potential of an area. Because, of course, the more light it is absorbing, probably the more photosynthesis you're picking up. And you'd be able to read that for not just the land, but also the oceans. So that's kind of interesting, right? Yeah. And so anyway, what looks like a map to you and me is really just a grid full of numbers. And there are interpreters that'll turn that into an image or turn your image back into numbers. ImageJ is a program that can do that. So here you go. Now do you see what it is? I think it's a golf course. Let's see, you got your front 9 over here. I'm guessing you come out of the clubhouse and go 1, 2, short par 3, 4, 5, 6, long number 7, 8, and 9. Or maybe that was 6, 7, 8, 9. Yeah, something like that. And I think that's the back 9. So there you go. It's a silly sport. I know. All right, so the job with image analysis is using all these different tools for image interpretation. And so there's a mix of processes that are going to be computer assisted, where you can train the computer to pick up certain patterns. You can tell it to only look for certain patterns. You can tell the computer only call this cultivated if it's over a certain threshold of light green color. Which would be from something like a grass, the type of chlorophyll that they have. And there's going to be a lot of manual procedures, like coming up with what's the hypothesis we're going to test, how are we going to test this by turning pictures into numbers, and then these are all the things that you can kind of work with. Size, shape, texture. Weirdly, you can build programs that will recognize different textures. You can do infrared imaging, which will tell you how hot things are. And so based on this, we know that, for example, the area around Fort Worth is very, very hot because it has a lot of concrete. And the concrete really heats up, and it has pretty much no trees. And so trees would normally absorb some of that heat and have a lot of water around there. And so, you can look at the effects of basically urban sprawl on local temperature rises, and do this over time with old and new satellite images and show exactly what's going on. It's kind of neat. So you can arrange these things, like color being the most basic one, and then things that have to do with colors, like pattern, size, size, shape, texture, height, shadows, and some of these patterns you will see best when the light is coming in from an angle. And so where possible, like where there are multiple images from a particular area, the people that do GIS will often prefer one where the sun is kind of sinking a little bit, so that you get nice shadows and nice contrast, because it'll let you see contours in the land that would be invisible otherwise, topography in general. Yeah. Okay, so there's some of the terms. Tone is something from white to black. Color is basically a wavelength. Yeah, and you can break that up in different ways. And the computer can basically, if you record the image with a good enough camera, with a sensitive enough camera that takes many, many little shades of gray, then you can actually analyze all of those, and you can get thousands of different shades of gray. And so you can have a lot of precision in your analysis because you have precision in the initial measurement. Now, if you were to put up your very own, satellite, and you put a really trashy camera on there, like I don't know, iPhone 1 camera or something like that, then probably you wouldn't be able to see as much. You wouldn't have as many shades to work with, and you would have similar data but with less resolution. So there you go. There's some colors. And yeah, look, you can see the greens are really green and they are a very different color from the forest. Just because grass is interacting with the light differently. You can also see that the cultivated fields over on the right-hand side, look at those. They're sort of a bright, kind of an acid green color. And so you can actually pick up what somebody's growing, what stage of growth it's in, whether land is sort of pristine, like covered in forests, or covered in sort of uncut grass, which would look something like that, or whether it's very manicured, whether it's in fact so thin that you can see the soil right through it, like all around here, which I think is the putting practice green for whatever this place is. All right. Next important concept is going to be resolution. So that's your ability to tell two different things apart, which we covered before in the section on electron microscopy. So yeah, for satellite, you can talk in terms of ground resolved distance, which is the smallest object that you can actually identify and measure. So here are some different resolutions of the same image, essentially. The resolution here is going to be basically how big are the pixels. So the pixels, P-I-X-E-L-S, they're little squares of a particular color. So each pixel has no variation inside of it. It's like one of the little dots that makes up your TV screen or your computer screen or your phone screen or an image. And this is how digital images are stored in little pixels. And so a pixel will have a color, basically a wavelength, but it can be coded different ways. It will have a brightness, and yeah, you can analyze all of that stuff. And so this is kind of neat. You actually have potentially 10 centimeter resolution on this one. So yeah, that's really tiny, and I think that's probably right. Yeah. I don't know where this is, but it kind of looks like the street where Harvey Mitchell joins on to Texas. I'm pretty sure it's not, but that's what it reminds me of. All right. You would also have size. Now, it's important. The satellites are going over at different angles sometimes for photographing things. And so there's a certain amount of error correction that goes into the images before you would actually get to them and use them. And depending on the time of day, you would also need to color correct. You could do that by comparing the color of a standard thing, like a white car or something like that. Would always look whatever white looks like, and then you can sort of set the white balance at that point. This is a thing that you've probably done when editing photographs. If it's too dark, you turn up the brightness, which is yeah, basically doing the same thing. You can look at the built environment and you can tell size. So if you look at an airport and it's got a wider runway and particularly a longer runway, that tells you that this airport can accommodate larger aircraft. For example, this is what people, at least in the government, I think, spend a lot of time doing with North Korea. You sort of look at the satellite images, and since you can't get any information out of the country, this is one way that you can at least see a little bit of what's going on in there. So we will pause right now while I recharge my computer and then pick back up and finish this section.